This is paper 1, video 5 for the February mock. First topic we're looking at in this video is all to do with recurring and terminating decimals. A recurring decimal is anything where one or more of the numbers repeat on and on forever. A terminating decimal stops, so at some point the decimal will cease and no numbers will be needed after it. So what we're going to be looking at here is trying to find out whether or not these fractions, when changed into decimals, would be recurring or terminating. Well, the easiest way of doing the first one, 1/4 or a quarter, we know is 0.25. Well, 0.25 stops after that, so we would say that this is a terminating fraction or a terminating decimal. For some of these other fractions, what's useful is to always try and make sure it is in its simplest form. So 2/18, I would start off by simplifying to 1/9. Now whenever you divide any number by a multiple of 3, the resulting number, the resulting decimal, will always be a recurring decimal. So here, because 9 is in the 3 times table, 1/9 is always going to be a recurring decimal. In fact, it is 0.1 recurring. So recurring decimal for 1/9. 3/15, well, I can simplify that. Dividing top and bottom here by 3 gives us 1/5. There's a couple of ways of checking whether or not that is a recurring decimal or not. Either we could use the Buss-Shelton method to change 1/5 into a decimal, or alternatively, if you change them into something a little bit nicer at the bottom for your denominator, so 1/5 for instance, I know if I times top and bottom by 2, that's the same as 2/10. Well, 2/10 can be written as 0.2, therefore terminating. 4/25, I'm actually going to use the exact same idea. I can change 25 into quite a nice number at the bottom by timesing top and bottom here by 4. The reason I'd want to do that is it would give me 16/100, or alternatively we would say 16/100ths. Well, 16/100ths is 0.16, so again a terminating decimal. 5/3, well, this, even though it's an improper fraction, we could change it into a mixed number. However, using the same thing that we did with 1/9, any time you divide by a multiple of 3, as long as it is not something we can simplify first, will always give us a recurring decimal. In fact, 1 2/3, that is what it would be as a mixed number, would actually give us 1.6 recurring. So that would be a recurring decimal. The next topic we've got, we are looking at tree diagrams, and more importantly, probability for tree diagrams. So it says we've got a bag containing counters, 3 red, 2 blue, and then a second bag with 2 red and 5 blue, and it wants us to fill out this probability tree diagram. So for the first pick, 3 out of 5 are red, because 3 red out of 5 altogether, so 2/5 will be probability for blue. In the second bag, because this does not depend on what happens in the first bag, we would have 2/7 for red, because there are 2 red counters out of 7 altogether, therefore 5 out of 7 for blue. Red on this line, as I said, it doesn't matter what happened on the first pick, so it's 2/7 and 5/7 again. It's then quite likely in exams that they'll ask you a subsequent question. Here it's said, work out the probability that Lauren takes 1 counter of each colour. Well, there's 2 ways that that can happen. She can either do red, then blue, or she could do blue, then red, getting 1 of each colour. So to find out the probability of red then blue, we simply read off the fractions on the probability tree diagram. Red from the first pick is 3 out of 5. Blue from the second pick is 5/7. And to find the probability of 2 things happening one after the other, we would multiply these two together. So 3 times 5 is 15. 5 times 7 is 35. For blue then red, we would do the same thing. So starting again, first pick was blue, so 2 over 5. Second pick is red, so 2 over 7. Multiplying these together to find out the probability of happening one after the other, we would get 4 over 35. We want either this or this to happen. When we want that in probability, one thing or another, we would simply add together the two fractions. So we'd do 15 over 35 plus 4 over 35, which would give us a combined total of 19 over 35. This being the probability of getting one of each colour. The next question is all to find gradients given two coordinates. Well, the main thing that you need to remember about gradients is that the gradient is equal to the change in y, we'll come on to that in a second, divided by the change in x. So when I say the change in y and the change in x, this is the difference between the x coordinates and the difference between the y coordinates. So for change in y, remember, got to be y on top. The change in y is the difference between the two coordinates that are going to be on the y-axis. So in this case 4 and 6. The difference between those two here would be 2, divided by the change in x, so the difference between the 2 and the 4, the two numbers that would go onto the x-axis. Difference between 2 and 4 is 2. So for the gradient, we would have 2 divided by 2, which is 1. For the next question, the gradient is again the change in y, so that is the difference between the two y coordinates, the two second numbers. So the difference between 5 and 7 is 2, divided by the change in the x coordinates, so the two first numbers in the brackets. Difference between 8 and 9 is 1, so 2 divided by 1 is 2, and this would be the gradient of that line. For the next one, change in y, here is 3. The change in x here, so the difference between 11 and 9 is 2. But because it has gone down from one to the other, we would actually say that that is minus 2, because the numbers have decreased from one point to another. We could leave the gradient as this, or if you really wanted to, 3 divided by 2 is 1.5, so 3 divided by minus 2 will be minus 1.5. For the final question, from 7 to 13, so your y coordinates, we would have a difference of 6. And for the x coordinates, from 10 to 13, it is 3. 6 divided by 3 is 2. There's also another question on this topic, or similar topic, at the bottom of this page. So it's asked us, does the coordinate 200, 405, lie on the line y equals 2x plus 2? If you need to find out whether or not a certain coordinate, a certain point, is on a line, all you would need to do is substitute the two numbers into the equation. Remember, the first number in a coordinate is the x coordinate, the second one is the y coordinate. So changing the letters y and x in this to these numbers, we would get 405 equals 2x, so 2 times 200, plus 2. And what we are looking for is if this point is on the line, the two sides of this little equation that I've worked out would be the same. So we are hoping that on the right hand side this equals 405. 2 times 200 is 400, plus 2 is 402. So in this case, not on the line. If these two numbers had turned out to be exactly the same, then it would have been on that straight line. The final topic for this video is all to do with circles and the equations of them. Well, equations of circles always look like this. X squared plus y squared equals r squared, where r is the radius of the circle. So whatever number is at the end, after the equals, if you were to square root that, that would give you the radius of the circle. So here, r squared is 25, so the radius of that circle would be the square root of 25, which in this case is 5. If the radius of a circle is 5, remember its diameter is double that, so the diameter would be 10. Same with the next one. R squared is always the number after the equals, so r squared is equal to 81. So the radius here would have to be the square root of 81, and that's 9. So the radius of the circle, shown by this equation, is 9. If the radius is 9, the diameter, remember, is double that, so 18. X squared plus y squared equals 50, same idea. So r squared would be 50. So to find the radius, we would have to do the square root of 50. Now don't forget, this is a non-calculated paper, so that actually doesn't have a square root, that is an integer value. So we could potentially do this in two thirds. Square root of 50, remember, is the same as the square root of 25 times the square root of 2, just splitting the root 50 up. And that would give us 5 root 2. So the radius here is 5 root 2 in third form. So the diameter would have to be double that. Remember, when you're timesing a third by a number, you can only times the number on the outside, the whole number. So this would give us 10 root 2. The radius here, well, the radius squared is 9. So square root of 9 is 3. So the radius is 3. Double it for the diameter, gives us 6. For the next one, again, it's going to be another one in third form. R squared equals 32. So r is the square root of 32. That doesn't square root to give an integer value, so I'd split it into two numbers that times together to make 32, one of which is square. So here I would have 4 root 2 as the radius. So the diameter would be double that and would be 8 root 2. Final question is the same again. R squared is 48. So the radius would have to be the square root of 48. That doesn't square root perfectly, it will give a decimal answer. So if we went into third form, that would give us root 16 times root 3. Remember, we always try and get a square number at the front here. And that gives us 4 root 3 as the radius. The diameter would be double that, so we just double the 4 to give us 8 root 3.